Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box there is some mystery math and your challenge is to figure out what it is. Today is a Friday, so that math is supposed to be more challenging. You can use the link in the description to try this out, and when you think you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. Okay, 0 gives us 1. How about a 1? So a negative looks like a non-repeating decimal. How about a 2? Interesting. How about a 3? We keep going down. How about a 4? All right, so the curve is definitely changing there. How about a 5? And a 6? Oh, and now it's headed back down again. I'm going to put in a 6.3 because the numbers are making me think trig here, and the fact that the curve is changing, its concavity makes me think trig too. And now it looks like, yeah, we're heading back down again. Huh. Let's do some negatives just to get a sense of this. All right, looks like it's continuing the same pattern there. Wow, that is a weird one. So in general, I'm thinking trig because you've got, well, if you turned it 45 degrees, it would be kind of that up and down pattern. It looks a little stretched out for a trig function. So I think maybe there are a couple of things going on here. If this is a trig function, maybe that's the place to start. If we've got a trig function going on here, looking at what it does at 0 is a good clue, first of all. So at 0, you put in an angle of 0, you read the coordinates here. We're at the point 1, 0. At 0, the cosine, which is the x-coordinate, is 1, and the sine is 0. We're at 1. So it looks like maybe this is cosine. And the cosine would start to go down, and it does. It just goes down quite a bit faster than you would expect. Let's put in an approximation for pi over 2 and just examine that point. So at pi over 2, let's call that 1.5. Huh. So isn't that odd? So at pi over 2, you would expect the cosine to be 0. So here you'd expect it to be 0, but it's a negative 1.5 when you'd expect 0. How about, let's think about pi. So at pi, the cosine would be negative 1 here. So let's put in an approximation for pi. Aha. Oh, isn't that interesting? So we would expect 1 at pi, and we got a negative 4.14 basically. Huh. So we expected negative 1 and we got negative 4.14. I'm seeing the same relationship there. So when we were at pi over 2, we put in a 1.5 and it should have been 0. We got out a negative 1.5. So how could you get that? Well, the easiest thing would be to add subtract 1.5 there. So you might have, the cosine of x and then minus 1.5. But when we get to pi, we expect negative 1 and we get negative 4.14 basically. We put in 3.14. So it's like it's subtracting what we put in from it, I think. And that would just be the cosine of x minus x. So, and it seems to work with those 2 points. It works with 0, right? Because you'd be subtracting 0 and the cosine of 0 would be 1. That makes sense. What if we put in a negative pi over 2? that'd be a negative 0.5. We'd expect it to be 0, but we're subtracting a negative, so it should be a positive 1.5. So if I put in 1.5, I should get out a 1.5. Or sorry, negative. If I put in a negative 1.5, I should get out a positive 1.5. And there it is. I mean, close enough. Huh. So I think we might have this. And I think we've tested enough points. I think it's worth the gamble. I'm going to check here. Yeah, the cosine of x minus x. Let's graph that. And there it is. That cosine waveform is almost recognizable. It's just been stretched out and slanted downward at 45 degrees. Wow, well that was a weird one. How did that go for you? Did you think trig? Let me know. Thanks everybody.